Where is the boombox going to be today? We're in the kitchen. Hi everyone! I have some rock candy with me here. They're a really fun snack. So today we're going to be learning about how to make them, and we're going to learn about rocks along the way. For this project you will need the activity sheet, which you can find on the Skokie Library website, sugar, some waterproof and heat-proof containers, so I'm using glasses, but you can also use jars or mugs, and some sticks. So I have chopsticks here, but you can also use skewers. You will also be using hot water, so you might need to ask an adult for help. First, let's dissolve the sugar into water to make a sugar solution. I'm going to mix together 3 cups of sugar. You can see that the sugar goes up to the 3-cup line with just 1 cup of water. That is a lot of sugar and not very much water. Do you think I can get all of the sugar to dissolve into the water? Well, let's find out. You can see how thick and cloudy this mixture is. The sugar has not dissolved at all. You might be able to hear the grinding sound of the sugar crystals as well. So what can we do? Well, we can heat it up. I'm going to do this in the microwave, but you can also ask an adult to help you bring this to a boil on the stove instead. What we are doing here is making a super saturated solution. If I use cold water, I can only get a little bit of the sugar to dissolve. When we use boiling water, the heat allows more sugar to dissolve than normal. But supersaturated solutions are unstable. This means that all of the extra sugar in the cup does not want to stay dissolved. What does that mean? Let's find out. Okay, so the sugar has dissolved now, and we can tell because the solution has stopped being cloudy and it's now clear. If I stick a thermometer in, it tells me that the solution is above 212 degrees Fahrenheit, which means that it's above boiling point. That also means that it's really hot, so we're going to have to let it cool down for 10 minutes before we start handling it. While we wait for the solution to cool down and become safe to touch, let's look for some rocks around the house. I have this very heavy mortar and pestle in my kitchen. I use it to grind up spices and garlic, and also to make guacamole. It's made of granite, which is a great example of an igneous rock, the kind of rock that you get when lava cools down really slowly, which allows lots of large crystals to form. So if you look closely, you can see how it's made of lots of minerals like quartz and feldspar. What else can I find? I know. I have some salt here. Salt is a really good seasoning for cooking because it makes food taste good. But it's also a mineral. There's a lot of salt in seawater, and there are some places that harvest salt by collecting seawater and evaporating all the water away to get the salt crystal. So salt is a crystalline sedimentary mineral. Now that 10 minutes has gone by, the sugar solution should be cool enough. What I'm going to do next is I'm going to dip my stick in the sugar solution, and then I'm going to dip it into sugar as well. This leaves me with a stick that is covered in sugar. So this creates lots of nucleation sites all over the stick, which will help the sugar grow onto the stick. What happens if you don't cover the stick with sugar? I started growing this sugar stick at the same time I started growing this sugar stick. But as you can see, this one is much smaller, and that's because the surface of this stick was smooth because it didn't have any sugar stuck onto it. And that meant that the sugar crystals grew at a much slower rate. So now I'm going to pour the sugar solution into the jars. I'm also going to add in a bit of food colouring to make it look a little bit more interesting. And then we're going to use some clips to keep our sticks from touching the bottom of the sugar solution. Loosely cover the jars with a towel and keep them somewhere safe. Within a few hours, you should start to see crystals beginning to grow. What's happening here? Remember how we found out that adding lots of sugar to hot water creates an unstable supersaturated solution? All of the extra sugar in the cup is leaving the water and precipitating onto the rough surface of the stick. This means that it's turning back into a solid. Also, water evaporates from the solution over time, decreasing the amount of water in the container, a little bit like how salt is harvested. This means that sugar will continue to precipitate out of the solution. Over the next week or so, you can watch the crystals grow until you are happy with the size of your candy. It might feel like a long time, but really, a week is a very short time to wait in the scale of things. Last year, I visited the Mole Creek Karst Caves in Tasmania. There were these stalactites hanging from the ceiling that had been formed by millions and millions of years of water dripping down and leaving behind mineral molecules. They're really spectacular, but I'm also glad that I don't have to wait a million years to eat my rock candy. So now that we've finished doing our experiment, it's time to clean up the mess we made. I'll see you another time, and as we say in the BOOMbox, what did you learn today? Even though that candy that we made today is called rock candy, it's not actually a rock or a mineral. Minerals by definition must be inorganic and natural, and sugar is neither of these things. Sugar comes from plants like sugar beet or sugar cane, so it's organic and it's man-made because humans had to process plants to make it. So this candy is not a rock.